Good afternoon, dear students. Now we are going to explain the topics of the chapter thermodynamics of class 11th. As we were studying on Google Meet, now today we are going to explain your next topics of the chapter is on progress, that is thermodynamics, and today we have the topic is modes of modes of exchange of energy between the system and the system and surrounding. This is the topic of the chapter thermodynamics. Okay, so very first we are going to exchange between the system and surroundings as heat energy. So as heat energy. So energy can be exchanged in case the system and surroundings are at different temperature or at different temperature and or also in and or also in thermal contact. Thermal contact. So here is a pattern of exchange of heat energy like this. System hotter than the surroundings, hotter than surrounding. Okay, so this is the surrounding like this. This is heat. Here is the surrounding and here is heat. If the system colder than the surrounding, if the system colder than surrounding, then the pattern will be like this, downwards, external to internal, like this. So this is the surrounding and here is presence of heat. So when the system are both in different position, here is the system hotter than the surrounding and here is the system colder than the surrounding. So the pattern will be like this of the surroundings and the heat. This is from the external position or vertically upwards and here is vertically downwards. So this is the difference in two systems. Okay, now 2 points as we have. So exchange of energy exchange of energy which takes place on account of the temperature on account of temperature difference between the system difference between the system and surrounding is known as heat heat and heat is represented by here small q. Okay, so heat is represented as a small q. So two important points to be created. So heat is positive if it is transferred from from surrounding the surrounding to the system. Okay, and another is heat is negative if it is transferred from the system to surrounding. Okay, so this system actually showing the negative because heat is transferred from the system to surroundings. So this is negative and here is positive. This is negative and this is positive because here is heat. Negative wise because the heat is transferred from the system to surroundings and here is heat is reaching from surrounding to system. Okay, so that's why there is two types of heat is positive and negative too. Now the next is work energy as a work energy. The next is work energy. Okay, so what's about the work energy? Here is two case also, work done during the expansion and work done during the contraction. Okay, so work is another mode of exchange of energy. Work is the mode of exchange of energy between the system and surrounding and surrounding. Okay, so there are two types of main work. There are two types of work which we generally come across. Okay, so this is the first one is electrical work, and the second is mechanical work. Mechanical work. Okay, so mechanical work is also known as mechanical work को आप प्रेशर वॉल्यूम वर्क भी आप कह सकते हैं, प्रेशर एंड वॉल्यूम. Okay, so mechanical or mechanic work is also called the pressure and volume. Okay, now in the two position of the work, so here is the observation. Let's find out or study. Let's study as to what happens when there is an expansion and contraction in volume. Okay, so these are two different cases as a work energy. So we are to find out in two both cases. So what happens actually? So first case is, here is the first case, work done during expansion in volume. So work done during the expansion, actually what happens as, so an ideal gas, suppose an ideal gas enclosed in a cylinder, fitted with a weightless and friction fitted in a weightless and frictionless piston having area of cross section equal to a. Okay, so let V is the volume, let V be the volume of the gas, enclosed in enclosed in P be the pressure acting on the system on the system. So which is slightly less pressure internal sorry less than the internal pressure of the gas. So we know that the pressure is the force, per unit area. Okay, so as we know that pressure is equal to force upon area, or F upon A. So the force will be pressure into area. Okay, so result of expansion, the piston moves as the pressure or the force is applied. Okay, so piston moves outwards through a distance dl. Okay, the small work done here, so here is the work done, this is the small work done by the gas on the surrounding will be or is. So as we have, and work equal to force into distance, or dw is equal to pressure will be reduced and area into dl. Negative sign, as we have used the negative sign here, this is negative sign, so negative sign okay, is used for the work done, by the system in case of expansion, okay, so in case of expansion in volume, so we know that volume will be area into distance del. So in this expansion from the finite volume, so in this case system expands from system expand from infinite volume V1 to V2. So during this change, work W by the system will be, so W equal to minus differentiation between volume del V equal to minus pressure change in volume V2 minus V1 will be minus P change in volume. So that's the equation in work done during the expansion. Okay, so now in contraction also we have in contraction, so that's the equation for the expansion in volume. Now in contraction in volume, so work the next is work done during contraction. So if the external pressure is slightly more than that of the gas enclosed in the cylinder so it will contract also. So this work is said to be done on surrounding by the system. So in this case V2 is less than V1 and work W will be pressure and change in the volume. It is for work done in isothermal and reversible expansion of an ideal gas. This is for the ideal gas. So the total work as you know, total work W done in the expansion of a gas from initial volume to final from initial volume to final volume V2 V1 to V2. So as we know the equation, work is equal to differentiation V2 to V1 into P del V. So for an ideal gas, you know PV equal to nRT, that is the gaseous equation, or pressure is equal to nRT upon V. This is for the ideal gas equation. So W will be W equal to differentiation from V to V1 and nRT having the values of P. So nRT is upon V into del V. So will be minus nRT differentiation from V to V1 into 1 upon V del V. Final equation will be minus nRT logarithm ln V2 upon V1 will be minus 2.303 nRT log V2 upon V1, because ln will equal to 2.303 log. Okay, so the for isothermal expansion, T is constant and V inversely proportional to pressure. So then W equal to minus 2.303 n RT log pressure P1 upon P2 will be final equation 2.303 n RT log P2 upon P1. So this is the final equation of the work done in isothermal and reversible expansion in ideal gas. So this is all for the today's topic, as we have already studied about this chapter and started as we were studying on Google Meet app. Today I have joined my YouTube channel in which I am restarting these topics of the thermodynamics chapter is going on for the 11th standard, which is beneficial to all the students of class 11th. So if you have feel any problem, you can comment in my box so that I can resolve your problem. Okay, so that's the topic of today's in modes of exchanges of energy about systems and surroundings that you are studying the topics. Tomorrow we would have another topics related to the same, because exchange of energy for the perspective of heat and energy has been cleared off. Now the internal energy and changes in internal energy is to be left out to finish this topic. And the laws of energy, first law of thermodynamics, which is very important topics for this chapters. Okay, so that's the end of this topic and today's class. So we will see you tomorrow. Okay, thank you.